Hello, good evening, all of you. Welcome to our session. Last time, we just started the discussion of our heart. I was telling you about the types of circulation that we see in vertebrates. Fishes are having single circulation. Amphibia and reptiles are having incomplete but double circulation. Birds and mammals are having complete double circulation. Do you have any doubt? ആർക്കെങ്കിലും സംശയമുണ്ടോ? Any doubt? Good evening, all of you. Any point to be discussed? Okay. So remember that heart is located in the thoracic cavity between the gap left between the two lungs, that is the mediastinum. So it is protected by a double-walled membranous bag called pericardium. It is a double-walled, outer and inner, having a small gap in between called cardiac or pericardial cavity, which is a fluid-filled cavity. That fluid is called pericardial fluid. Our heart is having 4 chambers. So we are starting the discussion of our heart. Simple diagrams. It is a 4-chambered one, having two upper chambers and 2 lower chambers. So 4-chambered heart. It is having 2 upper chambers for receiving blood. Remember, heart is the pumping organ. So it should receive blood and then pump blood. That receiving part is called atria or auricle. And I am drawing my heart. So this is my right side. So I will be marking this one as my right atria and left atria. Atria are thin-walled and they are separated by a small partition, thin muscular partition, which is called interatrial wall or interatrial septum. Inter means in between. So interatrial, in between the atria. Septum is cross-walled. The 2 lower chambers are larger. These larger chambers are called ventricles. So this is the right ventricle, this is the left ventricle. Ventricular walls are thicker and the walls of the left ventricle is the thickest. Remember, left ventricle is a bit larger than right ventricle and its walls are thickest. So here walls are thickest and this chamber is a bit larger than the other one. Generally, ventricles are larger than atria And ventricles are the chambers that will be pumping blood out of the heart. Heart na blood ne പുറത്തേക്ക് പമ്പ് ചെയ്യുന്ന. So heart pumps blood out of it from its ventricles. That is why its ventricles are stronger, thicker. Ventricles are having stronger and thicker walls. Okay. Right and left ventricles are separated by an interventricular septum. Interventricular septum in between the two ventricles. Now, you are having in between the atria and the ventricle, they are separated by a thick fibrous tissue, not muscular. It is, you please underline that part. Please underline that part. Separated by a thick fibrous tissue. Atrioventricular septum is this one. Atrioventricular septum is made up of fibrous, not muscular. This is muscular, this is muscular. But this is made up of connective tissue, fibrous. Fibrous tissue. In this atrioventricular septum, there are two apertures. They are called atrioventricular aperture. Aperture means openings. These openings are guarded by valves. The right atrioventricular aperture is guarded by a valve which is having three flaps. മൂന്ന് പാളികൾ ഉള്ളത്. So we call it as tricuspid. Having three cusp. That is the meaning. Having three cusp. Cusp is a term that is also present in teeth. നമ്മുടെ ടീത്തിൻ്റെ സർഫസിൽ പ്രത്യേകിച്ചിട്ട് ഗ്രൈൻഡേഴ്സിൽ we are having some small conical structures which are also called cusp. So the term that is common to teeth and heart, if such a question comes, then the answer should be cusp, two cusp, tricuspid. Similarly, the aperture on the left hand side, left atrioventricular aperture is guarded by a valve which is having only two flaps. So it's called bicuspid. Since it is resembling the mitral of the bishops, it is called mitral valve. Bicuspid or mitral valve. What is the function of these valves? Valves are allowing the flow of blood only from atria to ventricle and never back. ഏട്രിയത്തിൽ നിന്ന് വെൻട്രിക്കിളിലേക്ക് മാത്രമേ ബ്ലഡിനെ വരാൻ സമ്മതിക്കുള്ളൂ. തിരിച്ച് വെൻട്രിക്കിളിൽ നിന്ന് ഏട്രിയത്തിലേക്ക് മടങ്ങിപ്പോകില്ല. അതാണ് ഈ വാൽവിൻ്റെ ജോലി. ഓക്കെ. നൗ these valves are connected to some special muscles located on the walls of the ventricle. വെൻട്രിക്കിളിൻ്റെ ഭിത്തികളിൽ ചില പ്രത്യേക മസിൽസ് ഉണ്ട് which are all conical structures. They are called papillary muscles. ഈ papillary muscles are connected to the flaps of these valves by means of certain strong cord-like muscle tendons. ചരട് പോലെയുള്ള muscle tendons. So they are called chordae tendinae. Chordae means cord-like, stiff rod-like. Tendons which are cord-like, ചരട് പോലെയുള്ള സ്റ്റിഫ് ആയിട്ടുള്ള കോഡ് പോലെയുള്ള ടെൻഡൻ ആയതുകൊണ്ട് they are called chordae tendinae. 3 on this side, കാരണം there are 3 flaps here, 2 on this side. We are having only 2 here because they are having only bicuspid. What is the function of chordae tendinae? Chordae tendinae prevent the movement of these flaps into the atria. ഏട്രിയയിലേക്ക് തുറക്കാതെ എപ്പോഴും ഈ വാൽവുകളുടെ ഫ്ലാപ്പുകൾ വെൻട്രിക്കിലേക്ക് മാത്രം തുറക്കുക. ഒരിക്കലും ഇത് ഏട്രിയത്തിലേക്ക് ഇങ്ങനെ തുറക്കാൻ പാടില്ല. അങ്ങനെ preventing the opening of the flaps into the atria. അതിനെ പ്രിവെന്റ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് chordae tendinae ഉള്ളത്. Is that point clear? Now you got an idea regarding the structure of the heart? Any doubt? Now, what are the blood vessels that are all bringing blood and taking blood? നോക്കുക. Those which are all bringing blood are generally called veins. They bring blood towards heart. They are called veins. Remember, our heart is a double heart. Why it is called a double heart? Because right side is concerned with receiving impure blood and pumping impure blood. Left side is concerned with receiving pure blood and pumping pure blood. അങ്ങനെ രണ്ട് വശങ്ങളും രണ്ട് വ്യത്യസ്തമായിട്ടുള്ള ബ്ലഡുകളെ സ്വീകരിക്കുകയും പമ്പ് ചെയ്യുകയും ചെയ്യുന്നുണ്ട്. ഒരേ സമയം രണ്ട് വ്യത്യസ്തമായിട്ടുള്ള ഡയറക്ഷനിലേക്കാണ് ബ്ലഡിനെ പമ്പ് ചെയ്ത് കളയുന്നത്. That is why it is called a double pump. Right side is concerned with impure blood. So, from different parts of the body, impure blood is brought by important veins. They are called vena cavae. So, with the help of these vena cavae, impure blood is brought from different parts of the body and they are all opening by 3 separate apertures. അതാണ് ശ്രദ്ധിക്കേണ്ട കാര്യം. Sinus venosus is present only in amphibians, not in other higher vertebrates. These 3 veins are opening by separate apertures to the right atria. They are called vena cavae, important veins, or they are also called vena cava. Cava singular, cavae plural. Vena cava. And blood from lungs after oxygenation, that is pure blood, is brought to the left atria by means of a pair of pulmonary veins. So pulmonary veins bring pure blood from lungs after oxygenation, so it is oxygenated blood, and right side is receiving impure blood from different parts of, from all parts of our body. Okay. So, this is impure blood that is coming and that is being pumped. Here on the left side, pure blood from pulmonary organs, lungs, after oxygenation is coming and then it is pumped. Okay. Now, the impure blood that is brought by these vena cavae will be taken for oxygenation from the right ventricle by an important vein. This vein is called pulmonary vein. This is the blood vessel that is taking impure blood from right ventricle to lungs, to both lungs. Okay. And blood from left ventricle is taken to different parts of the body. What type of blood? Pure blood is taken by an important vessel called aorta or main artery. Aorta is the main artery that takes pure blood to all systems of our body. This is called aorta. So, blood is taken out by pulmonary vein from the right ventricle, and from the left ventricle, pure blood is taken through the aorta. Both these two veins. Okay. Sorry, there's a correction. Pulmonary artery. This is pulmonary artery. Both pulmonary artery and aorta are having valves at their opening. They are guarded by valves. These valves are having the shape of a half moon. So it's called semi-lunar valves. Semi means half. Lunar, moon. So having the shape of a half moon. So it's called semi-lunar valves. These valves are preventing the backflow of blood from the arteries to the ventricles. ആർട്ടറിയിലേക്ക് കയറിയിട്ടുള്ള ബ്ലഡ് തിരിച്ച് വെൻട്രിക്കിളിലേക്ക് വരാതെ നോക്കുക എന്നുള്ളതാണ് ഈ വാൽവുകളുടെ ജോലി. Auricle is atria. Auricle is also the atria. Is that clear? These two. Auricles are atria. Auricles are old names. Now it is called atria. Clear? So you studied the blood vessels that are opening to heart and arising from heart. Now, what is the structure of the heart wall? Structure of the heart wall is very simple. It is made up of specialized muscles called cardiac muscles. We are having very thick, powerful muscles called cardiac muscles. These muscles are different from striated muscles and unstriated muscles because they have some unique features. Cardiac muscles are having alternate dark and white bands. It is in that respect similar to that of the striated muscle, but they are all branched. These muscle fibers are branched and the branches are interconnected. Branches are interconnected. So it is the form of a network. Because of the network-like system, all the fibers are interconnected, and at the junction of two muscle fibers are muscle cells. Okay, muscle cells. There is a special structure called intercalary or intercalated disc. These intercalated discs are helping in easy sending of impulses from one to another. വളരെ പെട്ടെന്ന് തന്നെ ഒരു മസിൽ ഫൈബറിൽ നിന്നും മറ്റു മസിൽ ഫൈബറിലേക്ക് ഇമ്പൾസുകളെ കടത്തിവിടാനായിട്ട് സഹായിക്കുന്നവരാണ്. So that these muscles will be acting as a single unit. അതുകൊണ്ട് cardiac muscles are all contracting at the same time because of the intercalated discs. Clear? That is the special muscle, cardiac muscle. Remember, our heart is auto-excitable. നമ്മുടെ ഹാർട്ട് സ്വയം നിയന്ത്രിതമാണ്. At normal times, the functioning of the heart are controlled by the muscles of the heart itself. That is why it is called myocardia. Vertebrate heart myocardiac. Muscles of the heart are controlling the functioning of the heart. എന്നാൽ കോക്രോച്ചിന്റെ ഹാർട്ട് ഇൻവെർട്ടിബ്രേറ്റ്സിലൊക്കെ നമ്മുടെ ബ്രെയിൻ, അവരുടെ ബ്രെയിൻ, ആ അനിമലിന്റെ ബ്രെയിൻ ആണ് ഹാർട്ടിന്റെ പ്രവർത്തനത്തിനെ നിയന്ത്രിക്കുന്നത്. അപ്പോൾ നമ്മുടെ ഹാർട്ടിന്റെ പ്രവർത്തനം ഹാർട്ടിന്റെ മസിൽസ് തന്നെയാണ് നിയന്ത്രിക്കുന്നത് എന്നുള്ളത് കൊണ്ട് ഹാർട്ടിലേക്കുള്ള നെർവുകളെല്ലാം കട്ട് ചെയ്താലും heart will go on contracting as usual. Our heart is myogenic. It is myogenic. നമ്മുടെ മസിൽസ് തന്നെയാണ് ആ റിതത്തിനെ ഉണ്ടാക്കുന്നത്. ഹാർട്ടിന്റെ റിതത്തിനെ ഉണ്ടാക്കുന്നത് മസിൽസ് തന്നെയാണ്. മയോജനിക് ആണ്. ആൻഡ് ഇറ്റ് ഈസ് ഓട്ടോ എക്സൈറ്റബിൾ. സ്വയം മറ്റൊരു ടിഷ്യൂവിൽ നിന്നല്ല, ബ്രെയിനിൽ നിന്നല്ല ആ സിഗ്നൽ വരേണ്ടത്. മസിൽസിൻ്റെ അകത്ത് തന്നെ ചില പ്രത്യേക സംവിധാനങ്ങളുണ്ട്, അതുവഴി സിഗ്നൽ ഉണ്ടാവും. അതാണ് ഇപ്പോൾ നമ്മളിപ്പോൾ പഠിക്കാൻ പോണത്. മയോജനിക്കാണ്, ഓട്ടോ എക്സൈറ്റബിൾ ആണ്. ആരാണ് ഈ ഹാർട്ടിൻ്റെ പ്രവർത്തനങ്ങളൊക്കെ നിയന്ത്രിക്കുന്നത്? ഇറ്റ് ഈസ് കൺട്രോൾഡ് ബൈ ദി മസിൽസ് ഓഫ് ദി ഹാർട്ട്. നമ്മൾ പഠിച്ചു. അതിന് വേണ്ടിയിട്ട് there is a special type of tissue. That special type of tissue is called nodal tissue. There is a small nodal tissue, വളരെ ചെറുതാണ് ഈ നോഡൽ ടിഷ്യൂ, lying close to the upper right side of the right atrium. ഏട്രിയത്തിൻ്റെ ടോപ്പിനോട് ചേർന്ന് ഉള്ള ഒരു ഭാഗത്ത്. ഇറ്റ് ഈസ് കാൾഡ് സൈനു ഓറിക്കുലാർ നോഡ്, SA നോഡ്, which is called heart of the heart. ഇവനാണ് സാധാരണഗതിയിൽ ഋതത്തിന്, നമ്മുടെ ഹൃദയത്തിൻ്റെ താളത്തിനെ ഉണ്ടാക്കുന്നത്. നമ്മുടെ നെർവസ് സിസ്റ്റം എന്തെങ്കിലും ഒരു സ്റ്റിമുലസ് വന്നാൽ മാത്രമേ ആക്റ്റീവ് ആവുള്ളൂ. എന്നാൽ ഈ നോഡൽ ടിഷ്യൂ ഈസ് എക്സൈറ്റഡ് ബൈ ദംസെൽസ് വിത്തൗട്ട് എനി എക്സ്റ്റേണൽ സ്റ്റിമുലി. ബാഹ്യമായിട്ടുള്ള ഒരു സ്റ്റിമുലി ആവശ്യമില്ലാതെ തന്നെ സ്വയം അതിൽ സിഗ്നൽ ഉണ്ടായിക്കൊള്ളും. കൃത്യമായിട്ടുള്ള തവണകളിൽ സിഗ്നൽ ഉണ്ടാവും. ഓക്കെ, നോഡൽ ടിഷ്യൂ എന്നാണ് ആ ടിഷ്യൂകളുടെ പേര്. അതിൽ ഏറ്റവും പ്രധാനപ്പെട്ടതാണ് SA നോഡ്. SA നോഡ് ഈസ് കാൾഡ് ദി rhythm maker or pace maker. അതിനെ നമ്മൾ എന്ത് വിളിക്കും? പേസ് മേക്കർ എന്ന് വിളിക്കും, or rhythm maker. ഈ rhythm മേക്കറിന് ഓരോ മിനിറ്റിലും 70 to 75 ടൈംസ്, അതാണ് അതിൻ്റെ ഫ്രീക്വൻസി. ഒരു മിനിറ്റിൽ 70 തൊട്ട് 75 വരെ തവണ ആ സിഗ്നൽ സ്വയം ഉണ്ടാവും. അതിൻ്റെ ആവറേജാണ് നമ്മൾ 72 എന്ന് എടുക്കുന്നത്. സ്വയം ഉണ്ടാവുന്നതാണ്. എ സ്മോൾ ടിഷ്യൂ കാൾഡ് SA നോഡ്, വിച്ച് ഈസ് ദി പേസ് മേക്കർ ഓർ റിതം മേക്കർ, ഈസ് ദി പാർട്ട് ഓഫ് ദി നോഡൽ ടിഷ്യൂ. നിങ്ങൾ മനസ്സിലാക്കണം, നോഡൽ ടിഷ്യൂ ഈസ് നോട്ട് എ നെർവസ് ടിഷ്യൂ. ഇറ്റ് ഇസ് എ സ്പെഷ്യൽ ടൈപ്പ് ഓഫ് കാർഡിയാക് മസിൽ. മസിൽ തന്നെയാണത്. ഇറ്റ് ഈസ് നോട്ട് എ നെർവസ് ടിഷ്യൂ. ഇറ്റ് ഈസ് പാർട്ട് ഓഫ് ദി മസിൽസ്. എ സ്പെഷ്യൽ ടൈപ്പ് ഓഫ് ടിഷ്യൂ കാർഡ് നോഡൽ ടിഷ്യൂവിൻ്റെ ഭാഗമാണ് SA നോഡ്. നൗ there is another node lying very close to the and above the right atrioventricular septum. This is called AV node. ഇതാണ് AV node. This AV node is also capable of producing signals, but it is at a lower rate. എന്താണ് അതിൻ്റെ ഫ്രീക്വൻസി? ഇറ്റ് ഈസ് ഓൺലി 45 to 50 ടൈംസ്. അതാണ് അതിൻ്റെ ഫ്രീക്വൻസി. അപ്പോൾ നോഡൽ ടിഷ്യൂവിന് എല്ലാ ഭാഗത്തും ഒരേ രീതിയിലല്ല, ഒരേ ഫ്രീക്വൻസിയിലല്ല സിഗ്നലിനെ ഉണ്ടാക്കാനുള്ള കഴിവ്. ദേ ഹാവ് ഡിഫറെൻ്റ് എബിലിറ്റീസ്. പല ഭാഗത്തും പല പല കഴിവാണ് ഉള്ളത്. SA നോഡിനാണ് കൂടുതൽ ഫ്രീക്വൻസി ഉള്ളത്. AV നോഡിന് ലോ ഫ്രീക്വൻസി ആണ്. ഇറ്റ് ഈസ് കാൾഡ് പേസ് സെറ്റർ. ദിസ് ഈസ് ദി പേസ് മേക്കർ ഓർ റിതം മേക്കർ. AV node is called pace setter. ഇനി ഈ AV node is having attached to that a bundle of fibers. ഒരു bundle of fibers അതിൽ നിന്നും സ്റ്റാർട്ട് ചെയ്യുന്നുണ്ട്. This bundle piers of the septum. ഈ ഭാഗത്തുള്ള ഏട്രിയോവെൻട്രിക്കുലാർ സെപ്റ്റത്തിനെ തുളച്ച് ഇതാ ഇങ്ങനെ താഴേക്ക് വന്ന് ഇറ്റ് എൻ്റർ ഇൻ ടു the interventricular septum. After entering into the interventricular septum, it branches into two and runs through the anterior and posterior margins of interventricular septum. ഈ ഇന്റർവെൻട്രിക്കുലർ സെപ്റ്റത്തിന്റെ ആന്റീരിയറും പോസ്റ്റീരിയറുമായിട്ടുള്ള മാർജിനിൽ കൂടി വന്നിട്ട് they will be reaching the lowermost part. എന്താണ് അതിന്റെ പേര്? This part is called apex. ഹാർട്ടിന്റെ ലോവർമോസ്റ്റ് ടിപ്പാണ് അപ്പെക്സ്. നമ്മൾ എവിടെ പഠിച്ചത്? ലെഫ്റ്റ് ലങ്ങിന്റെ ഒരു കാർഡിയാക് നോച്ച് ഉണ്ട്. ആ കാർഡിയാക് നോച്ചില് ലെഫ്റ്റ് തിരിഞ്ഞു നിൽക്കുന്ന ഹാർട്ടിന്റെ അപ്പെക്സ് ഉൾക്കൊണ്ട് നിൽക്കുന്നു എന്ന് നമ്മൾ പഠിച്ചിട്ടുണ്ട്. ഇറ്റ് ഈസ് അക്കോമഡേറ്റിംഗ് ദി അപ്പെക്സ്. അപ്പെക്സ് ഇസ് ദി തിക്കസ്റ്റ് പാർട്ട്, അല്ലേ? ലോവർ പാർട്ട്. അതുവരെയും ഈ ബണ്ടിലിന്റെ രണ്ട് ബ്രാഞ്ചുകളും റണ്ണിങ് ത്രൂ ദി interventricular septum is passing. This is called AV bundle. This branches into idana AV bundle into a right and a left branch called bundle of His. It is called bundle of His. And after reaching the apex, it branches and gives a number of branches to the entire wall of the ventricles. വെൻട്രിക്കിളിന്റെ ഭിത്തി മുഴുവൻ ഇങ്ങനെ വ്യാപിക്കുന്നു. ആസ് വെരി ഫൈൻ ബ്രാഞ്ചസ് കാൾഡ് പർക്കിഞ്ചെ ഫൈബേഴ്സ്. ഒന്നുകൂടി പറഞ്ഞുതരാം. The heart muscles are also having a specialized type of tissue called nodal tissue, which is a modified muscular tissue, and this nodal tissue consists of an SA node and an AV node. Arising from the AV node, there is an AV bundle that pierces the right atrioventricular septum, emerges to the interventricular septum, branches into a right and left bundle of His, reaches the apex, and then branches throughout the walls of the ventricle as Purkinje fibers. ഇതെല്ലാം കൂടി ചേർന്നതാണ് nodal system. It consists of SA node, AV node, AV bundle, bundle of His, and Purkinje fibers, which is responsible for the rhythm and contraction of the heart. That is why I told you heart rhythm is initiated and maintained by the muscles of the heart itself. That is why we call it as myogenic. And it is auto-excitable. Are you following me? Any doubt up to this level? Anybody? Three papillary muscles, two papillary muscles, chordae, tendinae, string-like structures. Atrioventricular node, SA node, sinoatrial node. This is the AV bundle, which is dividing into two bundles of His, and then reaching the apex, branching into large number of branches called Purkinje fibers. The entire heart is made up of cardiac muscles. Walls of the ventricle are much thicker. First is cardiac musculature called nodal tissue. So that is what I was telling you. the nodal musculature has the ability to generate action potentials without any external stimuli. Nervous system is having that ability to produce impulses, potential, action potentials or impulses only when it is excited, only when it is stimulated by a stimulus. But here they are all auto-excitable. Ability to generate action potential without any external stimuli. That is auto-excitable. However, number of action potentials that could be generated in a minute vary at different parts of the nodal system. Underline that part. It varies at different parts. എങ്ങനെയാണ് ഇത് vary ചെയ്യുന്നത്? See, SAN can generate the maximum number of action potential, that is 70 to 75 per minute, and it is responsible for initiating and maintaining the rhythmic contractile activity of the heart. അതുകൊണ്ടാണ് it is called the rhythm maker or pacemaker. Okay. Our heart normally beats 70 to 75 times in a minute. Average is 72. Now, the structure is clear to you. Then, how the heart is pumping? What is the action of the heart? Remember, during pumping, heart is alternatingly contracting, dilating, contracting, dilating. Okay. One contraction followed by the relaxation is called one cardiac cycle. Contraction is called systole, and relaxation coming back is called diastole. So, systole followed by diastole. How the systole is occurring? When muscles are contracting, the chamber becomes smaller. That is the reason. When muscles are contracting, muscles on the heart walls are contracting, the chambers become smaller. When the muscles are coming back to the state, relaxed state, it becomes relaxed. Then the ventricles become, or atria become, larger in size. It is called relaxation or diastole. One systole followed by its diastole is called a cardiac cycle. Okay. So we are having a cardiac cycle. So understand these points. Cardiac cycle consists of systole followed by diastole. Again, both atria and ventricle are contracting one after another, not simultaneously. There is first atrial contraction. Only after that, ventricle contracts. Both are contracting one after another, that is successively. Atrium contracts, atrial systole, followed by ventricular systole. Okay. Similarly, atrium undergoes diastole. After that, ventricle undergoes diastole. So, contraction and diastole, systole and diastole are taking place successively. That is one after another, not at the same time. Okay. Let us see how this contraction is occurring. First, think that heart is not at all contracting and they are in a condition where both atrium and ventricle are in relaxed condition. It is called joint diastole. Joint diastole na both atria and ventricle are in relaxed condition. When atria plus ventricle relaxed, they are all in a relaxed condition. When atria is relaxed, remember, blood which is brought by the veins, both pulmonary vein and the superior and inferior vena cava. They are also called vena cava, superior and inferior vena cava, precaval vein and postcaval vein. They are filled with blood, so it is under pressure. But now atria is relaxed, its volume is large. When volume is large, the pressure inside that chamber is less. So blood is under high pressure inside the veins. Blood from veins enter into both atria, because in atria pressure is less. Why pressure is less? Because atria is in a fully relaxed condition. So there is less pressure inside the atria. So blood from veins enter into atrium. This is called atrial filling. Atrial filling. So atria is now full of blood brought by the veins. To the right side, we are having the impure blood. On the left side, we are having the pure blood. Clear? Now, a signal arises from SA node. An impulse is created, an action potential is created. Remember, it can produce signal by itself. And this action potential, a signal, an electrical discharge occur in the SA node. Since SA node is lying on the walls of the atria, this signal spread throughout the walls. So from SA node, it spread throughout the walls of atria. It spread throughout the walls of the atria. So what happens? When there is an action potential, an electrical discharge, the muscles contract. So when the walls of the atria is having that signal, you have atrial systole. Both atria are contracting simultaneously. These atria are now under contraction. So what happens? When the atria is under contraction, the chamber becomes smaller and smaller, correct? When the atrial chamber is becoming smaller and smaller, its volume is decreasing, pressure inside that is increasing, correct? So when pressure inside the atria is increasing, blood that is present will be entering. Remember, when atria is already filled with blood, 70% of the blood is entering from atria to ventricle. Why it is occurring, I will tell you at the end, then only it will be understood. Now, when atrium is undergoing contraction, the remaining 30% of blood enter the ventricles from atria. Remaining 30% of blood is entering now. How the blood is entering? Because the tricuspid and bicuspid valves are forced open because the pressure inside the atria is increasing. The valve is forced open and through the valves so it is the tricuspid and bicuspid AV valves. AV valves open and blood from atria to ventricles are flowing. Okay. Now you may be asking a very important question. Why the signal is reaching only the walls of the atria? Why it is not reaching the walls of the ventricles? Remember, the atrial walls and ventricular walls are separated by, they are all separated by a fibrous connective tissue which is in the form of a ring. This fibrous connective tissue ring is called here you are having fibrous tissues. This is called annular pad. Annular pad is made up of connective tissue, fibrous tissue. Remember, this septum is also made up of fibrous tissue. Atrioventricular septum is also made up of fibrous. And this fibrous tissue is forming a ring-like structure. Okay. You are having the atrial wall. This is the ventricular wall. Between these two, there is a thin layer of fibrous connective tissue. Fibrous connective tissue will not conduct impulses. Muscles will conduct impulse. Muscles are having good conductivity, whereas connective tissues are not. It is having fibrous connective tissue in the form of a layer separating the walls of the atria from the walls of the ventricle. This is the reason why the signals reaching the entire walls of the atria will never reach the walls of the ventricle. It should not reach. The signal should reach the entire wall of the atria but not the wall of the ventricle at the same time. It should contract one after another. There should be a small time gap. So, annular pads are helping that. Okay. You are having annular pads. Because of the annular pads, the signals are not reaching the walls of the ventricles. Now, how ventricles are contracting? Remember, you are having some internodal pathways. That bookilla. Internodal pathway. It is not in your books. We are having 3 internodal pathways connecting SA node and AV node. Through that, the signal will reach from SA node to AV node. Now, AV node will catch them, will amplify them. Now, from AV node, pass through the AV bundle, From AV bundle, it reaches the Purkinje fibers. Through Purkinje fibers, it reaches the ventricular walls. Remember, it is only after a small gap the signal has reached from SA node to AV node. It takes about 0.16 seconds. So only after that, signal reaches the AV node. From AV node, it is passed through the AV bundle, Purkinje fibers, then to the walls of the ventricles, ventricular walls. Now, ventricles undergo ventricular systole. Now, you are having ventricle undergoing contraction. Already, atria is contracted. Now, ventricle is also undergoing contraction. So, what will happen? When ventricle is contracting, the muscles are reducing their sizes. The volume of the ventricle decrease. So, volume of ventricles decrease. So, pressure increase. Correct. When pressure is increasing, that increased pressure will cause closure of the AV valves. See, AV valves are open. These AV valves are now closed. The flaps move backward so that it will close the AV apertures. Atrioventricular apertures are now closed. So, blood cannot flow back from ventricle to the atria because the openings are closed. The closure of the AV valves will cause a great sound. That is the first sound of the heart, which is called the love sound. First sound is caused because of the closure of the AV bundle. AV bundle closes when ventricle begins its systole. When ventricle begins its systole. Clear? Now, when ventricles are continuing its contraction, blood cannot go back because the AV valves are all closed. Blood will be under great pressure, and that great pressure will cause semilunar valves to open. When semilunar valves are open, blood from ventricle enter into the arteries. Blood from the right ventricle enter into the pulmonary artery, and blood from the left ventricle enter into the aorta, main artery. So, they enter into the arteries, pushing open the valves. Okay? When ventricle is contracting, atria is simultaneously relaxing. Atrial diastole. The contracted atria now become relaxed. When they are all relaxing, what happens? The volume is increasing. So, the pressure inside them decreases. So, atrial diastole causes pressure to fall inside the atria. Remember, blood in the veins are under pressure. Now, there is a fall in pressure, decrease in pressure within the atria. So, blood from you see, blood from veins are opening into the atria. So, this is causing atrial filling. Veins will be under pressure and atrium is now relaxing. Its pressure is decreasing, falling. So, pressure high in veins, pressure low inside the atria. So, you are having atrial filling. Now you got it? Atrial filling occur now when the atrium is in diastole. Atrium becomes full of blood. So atria is in diastole. So atrial diastole occur when ventricle is in systole. These two are all occurring simultaneously. When atrium is contracting, the ventricle is diastolic. Okay. That is the mechanism in which our heart is working. They are not contracting or relaxing simultaneously, but after a gap, successively. Now, when atrial diastole is occurring, we are having the atrial filling. Now, you are having ventricular diastole. Ventricle is now relaxing because it has undergone systole. Ventricular systole simultaneously occur when atria is in diastole. Now ventricle is in diastole. When ventricle is in diastole, what happens? Its walls are coming back to normal size. So the volume is increasing. Pressure inside the wall ventricles are decreasing. So pressure decrease. That fall in pressure or decrease in pressure will be causing. See, it was the increase in pressure that caused the opening of semilunar valves. Now the pressure is relieved, pressure is decreasing. So when the pressure is decreasing, you are having the semilunar valves getting closed. It was the systole that caused the valves to open. High pressure caused the valve to open. When the pressure is decreasing, immediately the valves are closed. The closure of the semilunar valves causes the second sound to be produced. This is the second sound, which is called dup. So you are having two sounds, lub and dup. I will come to that point later on. So semilunar valves are closed and blood cannot come back from arteries to the ventricle. And when ventricle is in relaxation, ventricle is in diastole. When ventricle is in diastole, its pressure is decreasing. That fall in pressure, low pressure in ventricle will cause blood from atria. It will cause flow of blood from atria to ventricle. 70% of the blood is flowing from atria to ventricle because ventricles are having a low pressure because its pressure is decreased because the volume is increasing. Atria already filled with blood. Blood already is poured into the atria. Ventricle now having less pressure. Because of that reason, from high pressure to low pressure, fluid flows. Okay, so 70% of the blood is flowing. Now you understand why I told you like that. 70% of the blood is flowing when you are having the ventricular diastole. So during ventricular diastole, 70% of the blood is flowing from atria to ventricle and remaining 30% of the blood is flowing when atria is in systole. Atrial contraction will cause 30% of the blood to flow from atria to ventricle, whereas 70% of the blood is flowing when ventricle is in diastole. Is that point clear? So when ventricle is also now ventricle is also in a diastolic condition. So both atria and ventricle are now come back to relaxation. It is called joint diastole. We started our study of cycle from joint diastole stage when both atria and ventricles are in a diastolic condition. Both are not contracted. It is called joint diastole. So from one joint diastole to the next joint diastole we have reached. This is the list of events which are occurring chronologically one after another during a cardiac cycle. Do you have any doubt? Order of events that are occurring when heart is in contraction. Remember, our heart will be pumping about 70 ml of blood. 70 ml of blood from one ventricle during every ventricular systole. This is called stroke volume. Amount of blood pumped from one ventricle during one ventricular systole is called stroke volume. It is 70 ml. And in a minute, 72 is the average. Frequency is 72. Okay. So, frequency of heartbeat is 72 per minute. So, every time heart is contracting, 70 ml is pumped. So, what is the volume of blood pumped in 1 minute? 70 ml into 72. Stroke volume into frequency. This is called cardiac output. This cardiac output is roughly, so when you calculate 5040 ml, which is rounded off to 5000 ml or 5 liter. So the value will be 5 liters. 5000 ml or 5 liters. This is called cardiac output. How you got that value? By multiplying stroke volume into frequency. Normally, our heart rate will be increasing when you are all doing vigorous exercises. Okay, so cardiac output will be increasing. An athlete who is doing regular workouts will be having his ability to change both the strength of contraction and thereby cardiac output. Okay. So this is what is given in a cardiac action. So there are two sounds heard. I will be telling that. First sound is the left sound. Second sound is the dub sound. Left sound is of long duration. It lasts long, 0.16 to 0.19 seconds. Whereas the second sound is only 0.1 second. It is high pitch. It is the high pitch dub sound. Whereas the first sound is left sound. First sound is the left sound. It is of longer duration, 0.16 to 0.19 seconds, and it is of low pitch sound. Clear? Any doubt? Anybody? Okay. In 1 minute, you are having 72, average 72. So we are going to a small calculation. Please understand this one. We are having in 1 minute, that is 60 seconds, 72 times. So 60 seconds, 72 times. So for one contraction and relaxation, that is for one cardiac cycle, the time is 0.8 second. So the time for cardiac cycle is 0.8 seconds. Clear? Now, what are the major events? I will be giving you a pie diagram to illustrate what are the main events that are all occurring during this activity. You can take down. Point 4 seconds. That is half of the 0.8 second is the time for joy and diastole. Half of the time heart is relaxing. Don't think that heart is getting no relaxation. It is continuously working. No. For most of the time, heart is relaxing. And atrium is in systole for about 0.1 second. 0.1 second is atrial systole. When atrium is in contraction for 0.1 second, atrial relaxation or diastole. Atrial diastole is for 0.7 second. So out of 0.8 second, 0.7 second, the atrial walls are relaxed. More time for relaxation. Now, 0.3 seconds is the time taken for ventricular systole, meaning ventricle is getting the remaining 0.5 seconds for its relaxation. So only 0.3 seconds it is contracting for 0.5 seconds. That is why I told you they are getting more time for relaxation. They are in a relaxed condition than contraction. So ventricular diastole is for 0.5 seconds. Remember, you are having the first sound occurring. The lub is produced when the ventricle is starting its systole, and ventricle is relaxing here, and ventricle is relaxing. On the beginning of the relaxing, you are having the dub sound. So, what is the gap between lub and the dub sound? It is 0.3 seconds. Gap between lub and dub is 0.3 seconds. And the gap between dub and the lub of the next one is 0.4 plus 0.1. So, 0.5 seconds. So, gap between the lub and dub is only 0.3 seconds, but the gap between the dub and the lub of the next cycle is 0.5 seconds. Is that clear? Any doubt? Anybody? These sounds are of clinical importance. Lub and dub sounds are very, very important in clinically assessing the functioning of the heart. Okay? And whenever you are all having a problem, your parents or grandparents are having a problem with the chest, they are all experiencing a pain, etc. Doctors will examine him. For hearing the sound, doctors will use a small instrument called a stethoscope. With the help of the stethoscope only, the sound can be clearly be heard. And after watching the sound for some time, they will be asking for doing a ECG. It was Eindhoven who discovered the principle of ECG. And Dr. Waller was the first man to record an ECG. What is that ECG? Understand, it is electrocardiograph. ECG is the electrocardiogram. The machine is called electrocardiograph. It is called ECG machine. ECG machine is called electrocardiograph, and the graph obtained is called electrocardiogram. What is that electrocardiogram? It is the electrical potential that is recorded when heart is undergoing its activities. When the heart is undergoing activities like systole and diastole, there will be potential differences, small potential differences. That electrical activity or potential difference of the heart during a cardiac cycle is graphically represented. That graph is called electrocardiogram. The graph is called, that picture is called electrocardiogram, and the machine is called electrocardiograph. To obtain a standard ECG, the patient should be connected with that machine at least with 3 electrical leads, one to each wrist and the third one to the left ankle. that continuously monitor the heart activity. But for a detailed evaluation of the heart, multiple leads, more leads, up to 12 leads may be used, and these additional leads are attached to the chest region. Then only you will be getting a continuous recording of the ECG, which can be either viewed in a screen or can be recorded on a paper, graph paper. And this is what a simple ECG will be looking like. It is having some peaks, up and downs, and they are all identified with letter from P, then QRS and T. P is representing the depolarization of the atria. It represents depolarization of atria. When depolarization occurs, the walls are contracting. So it represents atrial systole. Remember, this ECG is not representing contraction or dilation. It is only a graphical representation of the electrical disturbances, electrical activities that are all going on, potential activities that are all going on the walls of the heart. That's all. From that we infer when depolarization of atria occur, atria is contracting. So this is atrial systole. QRS is a complex of waves which is formed when there is a depolarization of ventricle. When ventricle is undergoing depolarization, which is a very stronger one, the peak is strong. So it is representing the ventricular systole. Remember, it is during the ventricular systole that the heart is pumping blood, which is the main function of the heart. So this wave is very, very important. During ventricular systole, you are having a peak. Remember, it is during the ventricular systole that atrium is coming back. It is coming back. That is diastole. So these two are all coinciding each other, so that there is no wave corresponding to the diastole of atrium, because diastole of atrium coincides with the systole of ventricle. Then the T marks the last part. Okay, this is the coming back. That is called repolarization. Coming back to normal. They are all again polarized of ventricle. T wave represents the repolarization of ventricle. QRS wave is occurring when ventricle is contracting. So the number of QRS wave in a minute is representing the number of times the ventricle is contracting. Okay, then the amplitude of this wave shows the strength of contraction. So if the QRS wave is very different from the normal, then they will say that heart is having a pumping problem. So from the number, that is frequency of QRS waves, and from the amplitude of the QRS waves, they will infer, doctors will infer, detect changes in the functioning of the heart. So ECG is a very important one. It is recording only the electrical disturbances, potential differences that are occurring on the walls of the heart during a cardiac cycle. Okay. P wave represent electrical excitation, that is, they are becoming active, or depolarization of the atria, which leads to the contraction of atria. QRS complex represents depolarization of the ventricle, which initiates the ventricular contraction. Contraction starts shortly after Q and marks the beginning of the systole. T wave represents the return of the ventricle from excited to normal. That is called repolarization. End of the T wave marks end of systole. Okay. By counting the number of QRS complexes that occur in a given time period, one can determine heartbeat rate of an individual. Since ECG obtained from different individuals have roughly the same shape for a given lead configuration, any deviation from its shape indicates a possible abnormality or disease. Hence, it is of great clinical significance. Okay, so that's about the ECG. Any doubt from this part? Anybody? Okay. So please read the NCERT book very carefully, and if you are having any problem in understanding any word or any sentence, please bring it to my notice next time. Okay. So it is time for me to say goodbye to you because our time is almost exhausted. If you are having no doubt, I will say good night and goodbye till we meet next time, next week. So thank you all. Thank you very much.